Hello everybody, so I'm doing the Advent of Code challenges on the Acorn Electron again. This morning I did part 1 of day 1, so now I'm going to finish that and do part 2. So I had a chance to look at what part 2 is, and it's the same challenge, but instead of finding a combination of two numbers from the list added together that result in 2020, you have to add three numbers together. So this is a good example of what I was saying about the part 2 throwing you a curveball, because I guess if you did the simplest solution to part 1, which you just had a loop over all the values and then another loop within that over all the values again, you would have an order n squared algorithm. And I guess if you applied the same method this time, where you try and find three numbers, where you have 3 for loops embedded together, you'll end up with an order n cubed algorithm, which might take too long. And probably on the Electron would just not be possible. So I guess that shows sometimes it's worth trying to think of a more efficient way to do part 1, even if it doesn't necessarily matter for just part 1, because then part 2 will make you need the optimizations to run in a reasonable time. Okay, so I'm going to load the program that we wrote in part 1. If I can find it. Hang on. Okay. Just make that go faster because it's boring waiting for the tape. So just we'll list the program for a reminder of what we did. Okay. So I think to implement part 2, we could just add another for loop outside the first one, and iterate the numbers again, but I think it will probably be quite slow. So it would be nice to speed it up a bit, just to do some tweaks to the part 1 to make part 1 go a bit faster before we make it run with the part 2 mode. So I think one thing I'd like to do is just do this little has number function in assembler. It's just because I don't like this little raising 2 to the power of thingy in the source code, because I can imagine that's probably implemented with some loops or something in BASIC, but it should just be a really neat little operation. Because obviously computers are really good at multiplying by 2, so if we do that in assembler, it will be a lot faster. So if we just start writing a little assembler routine at the end of the program. So we'll make a procedure that assembles the assembly. The BBC Basic has a really nifty assembler built in, so we can take advantage of that. So we can reserve 100 bytes of memory for the routine. Okay, and then start writing the assembly. So when you use the assembler in BBC Basic, the assembler is sort of embedded in your basic source code, so when you assemble some assembly code, you usually have to make at least 2 passes so that you can work out where the addresses are. And then on the BBC you can do that with you actually have to write the 2 passes yourself. So that's why I'm making a for loop to to run the assembler, and then you have to set P, that's a special variable to set the output address of the assembly. So I'm going to set it to those 100 bytes that I just reserved. Okay, and then a square bracket to start writing some assembly. Set the optimization mode. So in the first iteration of the assembler, you want to turn off the errors so that when it jumps to a label that doesn't exist yet, it doesn't complain until the second time you compile. Okay, so so start the routine. We're going to make the routine have so in X we'll let BASIC set this up for us. So in X, the register X, we'll have the number that we want to check divided by 8, and in Y, I'm just writing comments there, and in Y we'll have the bit number, so that will be like the number mod 8, whatever. Okay, so first of all we want to do this 2 to the power of thing, which I wanted to write in assembler, yeah, because it's much simpler in assembler. So we'll start off with A as 0, and then we're going to do a loop with a series of rotate instructions. So we want to do Y rotate instruction, so a rotate instruction Y times. So going to set the carry flag, because of the way the 6502 assembler works, it's easier to do loops that count down and then always run once. So then I can just decrement Y at the end. So I'm going to always do at least one rotate instruction. So the first rotate instruction will change the 0 in the accumulator from 0 to 1. So I'm going to rotate in the carry, so I'm going to set the carry to start with, and then actually, yeah, I don't need to do rotate, I can just do yeah, so I do one shift, so that will put the carry into the first bit and the first time, and then after that the carry will be set to 0 because A was 0, so the overflow bit will definitely be 0. So then we want to decrement the Y, which is the bit number, so that and then if that becomes a negative number, then the negative bit, the negative flag will be set, and then that means we want to stop the loop. So for example, if the bit number was 0, then we only want to do it once, so it would decrement Y from 0, and then Y would become -1. So we want to stop when it's negative. So we want to continue the loop when it's positive. I think the instruction is BPL. I don't know what the L stands for, but it's something like branch positive. So loop. So continue the loop. Okay, so I forgot to write the label. So I'll add that in now before I forget. So that makes the label. Okay, and then carry on where we were. Okay, so now I want to so I've got in the accumulator in A, there will now just be one bit set, depending on what the Y value was, and now we want to use that bit to compare with the data that we had. So I know that the data is stored at an address called values, so and I can just test that bit using the AND instruction. So I can just test with from the values array offset by x. Oops. So now the accumulator will be 0 if the number isn't in the array, and some other value if it is. Okay, so I'm going to call this routine from basic, so I want to be able to access that accumulator value from basic, so I'm just going to stick it somewhere that basic can get to it, so just stick it at an address 70. Store A at address 70, and then return from the subroutine. Okay, so close the bracket to stop being in assembler mode, and then end the for loop. Okay. So I think we can just call that procedure to check whether that assembler works. It didn't work. Oh, well, because that variable is defined in line 10. Okay, but it'll probably work. So now we want to, so I've just defined a procedure that assembles the assembly routine. So now we need to remember to call it somewhere, so we might as well do it right at the beginning. I think I called it make prog. Yes. Okay. Okay, that's probably fine. And then we need to change this that has number function to use the function we defined instead. So we can just overwrite the function that we had there, and so we need to pass in the X register. So that will be what we had already. So that will be number divided by 8. And then in the Y register, we just want the number modulo 8. So and 7. Okay, so that gets rid of that horrible raising to the power, and then we can call that procedure the assembly procedure, and then the result we stored in 70, the address 70, so we can just read that out. I don't know why I put a bracket there. Okay, just read that out and make it a true or false value, so by comparing it with 0. Okay. I think we could run it now, and so it's assembled the program and just stopped. Is that because I forgot to write nprog at the end? Yes, that's good. Probably that. Right, I forgot to add the nproc, so it just called the procedure and then hit the end of the program and stopped. Okay. So, 9:30. What happened there? Percent. Okay, so I've clearly forgotten what I called it. Prog percent, not proc percent. Okay. What line was that? Okay. Oh, it was at line 3000. Okay. I don't know why I made this so confusing. Okay. make it run at full speed. So let's just see if it didn't give us an answer. I guess it didn't work. Let's have a look. What did I do? So starts off as 0, sets the carry, shifts A, and then decrements Y, and loops until it becomes negative. And then we read the values. Yep. Maybe that's not the right instruction. I think I'm going to look it up. You can't see what I'm doing. I think maybe that shift instruction doesn't add in the carry. So yeah, so that shift instruction doesn't add in the carry. So I want not that one. I want the one that does add in the carry. So I'm going to change that shift instruction to, I think it's rotate left. It's so confusing. Okay, and then let's try it again. Make it go full. I got an answer. Okay, so I think that's the same answer we had earlier today. So that means the assembly routine probably works. That's great. Okay, so the next thing, there's probably loads of things we could do to make this program faster. But the other thing is, as you see when we run it, it finds two solutions, which I guess means that the for loop, it's pointless doing the for loop through the whole range of numbers, because it could just stop at after it's gone to the first half, because yeah, the other half it would have found it in the first half. So we can just loop through just half of the numbers. So I'm gonna make, because it will make it easier later, I'm gonna add a line in, add a variable to set the target that we're looking for. So the target for part 1, I don't know why I got an equals there. So the target for part 1 is 2020, and then we're going to make the loop just the second half of the range of numbers that we want. So instead of going from 1 to 200, we're going to go from half of the target to the target minus 1, because, well, yeah, there's no point, there's no zeros in the list, so we can go to minus 1. Okay, let's check if that works as well. Okay, yeah, and then it stops earlier, it doesn't find the second result. So now we can do part 3, part 2, getting ahead of myself. So we can just add another loop around the whole thing. So let's go start with J, from 1 to 2020. I'm going to change the line number because I'm running out of line numbers. Okay, from 20. Okay, so then now the target, instead of being 2020 for the inner loop, will be whatever 2020 minus the value that we just had was. Okay. Okay, so the end of this outer loop, I'm going to make it line 85. So if I list the whole thing and make it clearer. So we've got 2 loops there. So that's going to loop through all the numbers, but actually we want the outer loop to skip numbers that aren't in the list. So I'm gonna have to use a go-to. Yeah, so we really want like a continue statement to continue the for loop, but yeah, basic doesn't have that, so we have to do a go to line 85 to continue the loop instead. So I want to test if the number that we're checking for not has, we want to stop when it doesn't have it, so so yeah, if the number isn't there, oh no, it's not in the list. What am I doing? Sorry, just okay, then go to 85. Okay, so then so I think that might be it, but now it won't tell us. It's not going to print this j variable out, so we want to change what happens when it prints the solution. I'm going to make this found function take the j variable as well, so that it can print it out. And then I have to try and find where I put that. Okay, so this is the found procedure. So now it needs to take an extra argument, so we can change line 100 to add in the extra argument. I'm going to make them all shorter. Okay, make this simpler, and then the other, I'm just going to call it C instead. So the third variable is the overall target that we had minus the combination of the two numbers that we passed in, and then we can change the print statement to print all of the numbers out. A C and then we want, okay, let's let it do that. Is that right? Yes, probably. And then we'll print out the answer as well. So that will be the multiplication. This is the number that we want to type in into the web page. So it's the multiplication of all the numbers. Okay, so hopefully that is everything. Let's try running it and see what happens. It's going to probably take a while because now it's got yeah, we're back to an n squared algorithm because we've got a loop within a loop, but it's already found an answer. So it's a loop within a loop. It's going to loop. Well, it's complicated to work out, I guess, because yeah, the inner loop doesn't loop through all of the numbers. It just loops through a subset. That's probably not good. It's found two different answers. Well, they can't both be right. Do either of them add up to let's see if either of them add up to 2020. Yes. Okay, they both do. So one of those numbers probably isn't in the list. Well, it's probably the outer number. Let's see what this routine thinks of it. Oops. Is that in the list? Yes. What about the other one? As well. Okay. Does that mean the routine that has numbers wrong? Let's check whether all the others are in there as well. No. Okay. What about 132? No. Okay. So my C number is all wrong. How did that happen? What was the C number again? Oops. It's really annoying trying to look at the code, I'm sure. Okay. So the C number is just 20 minus the sum, so yeah, I guess that means yeah, let's look at the loop again. Who knows what I did. So the outer loop is j from 1 to 2020. If it's not in the list, then skip it. Okay. Then we need to look for a target. I forgot to update the target there, so I'm still searching for a number that adds up to 2020, whereas I'm supposed to be looking for a number that adds up to whatever the current target is. So now what does it do? It's taking a bit longer, I guess that's probably good. Okay, found one answer. Is it the right one? We'll let it think for a bit and see if it finds another one. Otherwise I have to try and type that really long number into the website to see if it's the right answer. So this is, I haven't sped it up, it found that that quickly. But I guess, yeah, it's sort of luck of the draw in that case to see whether your answer happened to be right at the beginning of what it was searching through. So probably should let it run through the whole thing before we judge whether it's fast enough or not. Well, I'm going to type in the number anyway while we're waiting. I'll let it run. So 157667. 157667328. Yeah, that's the right answer according to the website. Okay. So that's good. Still really slow. It's still taking a really long time to finish the entire loop. I guess you could probably just make it, yeah, well, there's probably loads of things. Yeah, and it's going to find it's the same answer several times. Yeah, because I guess yeah, the outer loop is going to put the outer variable in every position. So there's probably loads of things you could do to speed that up. So I think the main obvious thing is that it's iterating over all 2020 values and just skipping it when it's not in the list. So what I probably should have done is, as well as having that bit array of values that are in the list, actually just have an array of the values, because there's only 200 of them. So that way it could just iterate over the array and just directly jump to the values that are available, and that would make the loops a bit shorter. I'm sure there's probably lots of clever ways to do this, but anyway, that's the only thing I came up with. So I'll stop it there. So thanks for listening. Goodbye.